Counting cards, chapters 3 and 4. Here's a standard deck of playing cards. There's 4 suits, spades, hearts, diamonds, and clubs. Each suit has 13 ranks, and there's 1 card of each rank. So the ranks are King, Queen, Jack, 10, 9, 8, 7, 6, 5, 4, 3, 2, and ace could be either high or low depending on the sometimes depending on the game, or sometimes but anyway, 2 of the suits are red. Hearts and diamonds are red, so that's half the deck, and the other 2 suits are black. Spades and clubs are black. Total of 52 cards. Okay, so in this example, 5 cards are dealt from a standard deck. What is the probability of a full house? That's 3 cards of 1 rank and 2 cards of another rank. So there's 13 choose 1 ways of choosing a rank for the 3 of the same rank. Once the rank has been chosen, there are 4 choose 3 ways of choosing the suits. So for example, if the chosen rank was king, there are 4 kings, 1 of each suit, and we would have to choose 3 of them. So then, okay, so the for the 3 of the same rank, 13 choose 1 ways of choosing the rank. Let's say it's kings, and then there's 4 kings, 1 of each suit. Once we've chosen the rank, there's 4 choose 3 ways of choosing the suit. And then once we've chosen the 3 cards, there are 12 ranks left, and there are 12 choose 1 ways of choosing a rank for the 2 cards of the same rank. Once the rank has been chosen, there are 4 choose 2 ways of choosing the suits. So for example, if the chosen rank was ace, there are 4 aces, 1 of each suit, and we would want to choose 2 of them. So okay, so once we've chosen the cards for the 3 of a kind, there's 12 ranks left. We want to choose 1, for example aces, and once we've chosen the rank, then we need to choose the suit. For example, there's 4 aces, 1 of each suit. We want to choose 2 of them. And then the denominator is going to be 52 choose 2, because there's 52 cards in the deck, and we want to choose 2. Then we can, on the calculator, we can do this computation. 13 PRB right arrow 1 equals 13. 4 PRB right arrow 3 equals 4. You could do these by hand, especially the smaller numbers, but for problem this involved, it's okay to use a calculator. You should be able to do actually the smaller numbers by hand. 12 PRB right arrow 1 equals 12. 4 PRB right arrow 2 equals 6. 52 PRB right arrow 5 equals 2,598,960. So the sample space consists of these 2,598,960 ways of choosing 5 cards. The desired probability, we just multiply these first 4 numbers and then divide by the size of the sample space. So it's 13 times 4 times 12 times 6 divided by 2,598,960, and it comes out to be approximately 0.01. So this is a pretty low probability. The 1 is in the thousandths position, and so it's about 1 in 1,000 chance of getting a full house. So if you get a full house, that's a pretty good hand, and you might want to bid pretty high on that hand. Of course, some people play with wild cards, and that will change the probabilities. So if you're playing with wild cards, then a full house maybe is not so unusual. Okay, example 2. 5 cards are dealt from a standard deck with a probability of 2 pairs and 1 unmatched card. So example would be 2 queens, 2 tens, and a 7. So 2 queens would be a pair, 2 tens would be a pair, and 7 would be an unmatched card. Okay, so there's 13 choose 2 ways of choosing the ranks for the pairs. So, for example, let's say queens and tens. Once the ranks have been chosen, for example, queens and tens, there are 4 choose 2 ways of choosing the suits for each rank. So there's let's say we chose queens and tens for the pairs. That's 13 choose 2. And then for the queens, we have 4 queens. We want to choose 2. There's 4 queens, 1 of each suit. We want to choose 2. And there's 4 tens, 1 of each suit. We want to choose 2. And then once we've chosen the pairs, there are 12 ranks. Should be 11 ranks left. And there are 11 choose 1 ways of choosing a rank for the unmatched card. And then once the rank has been chosen, for example, if we chose a 7, then there are 4 sevens, 1 of each suit, and there's 4 choose 1 ways of choosing which of the 4 cards. And the denominator again is 52 choose 5. So again, we can put this on the calculator, and 13 PRB right arrow 2 equals 78. 4 PRB right arrow 2 equals 6. 4 PRB right arrow 2 equals 6. 11 PRB right arrow 1 equals 11. 4 PRB right arrow 1 equals 4. 52 PRB right arrow 5 equals 2,598,960. So that is the size of our sample space here. For the probability, you want to multiply these 5 numbers here and then divide by the last number, and it comes out to be 0.047, or approximately a little bit less than 0.05. So it's still a pretty good hand. Two pairs and 1 unmatched, still a pretty good hand. Not quite as unusual as the full house, but it's still a good hand. And that concludes this presentation.